What's up, guys? Welcome back to another episode of the Oil and Gas Startups Podcast. We've got the guys with Amplified Industries here today. Y'all changed your name, right?
Acoustic Wells before.
Yeah, that's right. I was trying to remember because I remember you guys came by. God, it must have been 3 years ago.
Mm-hmm.
I think we were on the other side of the building. You told us a little bit what you're working on. I know it was kind of early stages back then, but I'm excited to kind of dive into what you guys are working on now, how things have evolved. So really quickly, for everybody listening, what is Amplified Industries?
Sebastian here, CEO of the company. We build the next generation of automation and control system for the oil field.
Okay, so at the well site?
At the well site, from the equipment on the wells to the math running on the cloud and anything in between.
And on top of that, not just like your device is going to go physically there, but all the data pipeline that allows you to get that at very high resolution, very high quality, all the way to a cloud, process into actionable insights.
So is this more like on the production optimization?
Exactly. Yeah, we help the production engineers mainly today. So you have your guy in Permian who's in charge of a couple hundred wells. Put the system there. The wells are going to run as much as possible on autopilot basically with the system, and then he can dive in and use his expertise to do real in-depth, understand what's happening on every well. Especially on all the new wells, there's all kinds of complicated flows basically that happen because of those big horizontals and lateral legs. And that's where we come in. We allow him to, get this big picture view, dive in where he needs it, and let everything else, run automatically, let the system do its job where he doesn't need to dig in.
Mm.
And at the same time, the guys in the truck were like running their routes, making sure that everything is going the way it should be. They have our app, and as soon, a well goes down, stop pumping, they know about it. They lose pressure on the flow line, they know about it. They have a tank that's full, they need to get sold, they'll know about it. So both in the office, like high level, doing very, very nitty-gritty technical deep dive, but also at the operational level, making sure that everyone is aware when something bad happens and can be on top of it and go fix it.
So kind of like this pump by exception thing that we've been chasing for a long time,
Yeah,
of like just being able to know exactly what is going wrong, be able to almost like create tickets, I would suppose, and
literally
dispatch the pumpers there, and then work hand in hand with the engineer who's kind of like behind the scenes to optimize production.
Yeah, that's one of the interesting things. You have all those layers from, the foreman on the ground, the engineer in the office, and more the executive guys that want higher level, different analytics, different visualization for different job position at the end of the day. And building that out there for different kinds of company from your small mom and pops to your larger independent producer, your company with a nice tower in Houston, and anything in between.
So what are y'all's backgrounds again?
So let's see. Depends how far you want to go there.
You want to go next first?
Yeah. I'm French. I've been here since 2012 in the US.
Okay.
I used to be in quantum physics in France and then in aerospace. Ended up pretty randomly, honestly, doing an internship with Schlumberger here. They had their research center right across from MIT. I was like, why not? And I loved it. I was very impressed with the work I did over there. Ended up doing the whole PhD with them on pump jacks, model the flow, the waves, the sound, all the physics that happens on the ground. Gave me a few ideas of my own and decided to start a company. So I kind of blended a lot of I worked with Siemens on turbo machinery. I worked at aerospace company before and bringing all those mindset to, the oil field and the upstream sector.
So that's wild to me. What was like the allure of, was it SLB as a company, or did you become completely enamored with like the industry? Because I mean, if you're coming from like aerospace, that just sounds like the coolest industry in the world to work in my opinion. So like, what was like the draw for you?
The draw was, I like big industrial toys, right? Like kind of classic mechanical engineer mindset. You're making an impact and all those large machines. And Schlumberger is an extremely high tech company. And like we were building miniature particle accelerator to put in tools that are brought downhole. And I didn't expect that. And through them, I got to go discover all kinds of oil field. And I just loved, the first time I was on some Oklahoma fields in the South. And I just loved going there, like talking to the pumpers and all that. And it was the most, extreme difference between my experience, which was like in France. I was in the rocket engine factories for Ariane, like, you know, sterile environment with like two guys, basically surgeon assembling something in detail, to like some scorching field in Oklahoma with the pumper and his cigarette. So very different. But at the end of the day, the oil and gas industry deals with real important problems, and that's why we wanted to help. It's we saw a need for it, technically speaking. We saw that there was also a change of generation coming. Frankly, there's bunch of new engineers, new generation like you guys, that are a lot more open to change the industry and adopt new technology and all those all those buzzwords, AI and so on. And decided to be part of this.
Do you come from the industry as well?
Yeah, so my background is somewhat similar. So I'm also French. Seb and I actually know each other from, at this point, 15 years ago, undergrad. My background is initially very mathy and physics. And I sort of had this oddball class when I was in college about basically energy, and very focused on making us realize how central it is to basically modern civilization. And like energy is the lifeblood of everything. Like there's petroleum product everywhere in this room. Like this is plastic, it's petroleum, synthetic fibers, petroleum, and all that sort of stuff. And initially I wanted to go actually in nuclear engineering. That was the kind of stuff I was more coming from this fixed background. That was exciting. Pretty quickly it became clear to someone with a little bit of foresight that the French nuclear industry was not going anywhere. And so I figured, okay, so Schlumberger had this really good reputation as like excellent top tier technical company. That was, and I figured, okay, I'll go do an internship there. I'll be in sort of like the engine of the world. And it was 2012, first time I worked in the industry. And I mean, it was a crazy time. Like it was peak oil, everything. The shale revolution was starting maybe to happen in the US, but everyone was looking for the crazy next place from which the next barrel would come from. So Arctic project, deep offshore, pre-salt in Brazil, and eventually shale was really stuck. But so it was there, and I've realized it was kind of the same thing, basically really, really, really technology intensive in some ways. But then I got my PhD in math working with Total, which is a French oil major. And it was interesting because it was oil and gas is this weird place where a lot of what we'd consider computer science, digital technology come from there, like high performance computing. The people who made it are basically either nuclear bombs simulations or reservoir simulations, this kind of stuff, seismic, like the drilling technology. It's like crazy, like rocket science, literally. And on the other end of the spectrum, like a lot of the more like user-facing digital stuff, the automation system, all of that is super old school. And so really got interested into, okay, how can you, this is a big industry with a very big impact that's, going to be with the world for a long time and has a lot of responsibility and stewardship to own, basically. And how can you use like those new tools that have starting to come from other places and bring them in this industry, which is dealing with these massive problems, super interesting systems, to be honest. Like if you go to a drill location, like any production facility, it's like, okay, that's real interesting stuff going on, and how to bring all of those technologies to this industry. So I've worked reservoir with Schlumberger. My PhD was more on process optimization on the downstream side, did some work on offshore drilling when I was at MIT, and now production optimization.
Nice. So how did the kind of concept come up? Was it just seeing a need for this at SLB and just being like, well, if no one else is going to build it, we will?
So the concept didn't come from SLB. I got exposed to the industry while at SLB. And going on some field, I basically saw how oil wells are controlled. And frankly, I thought we could do much better, right? Even on, first, most oil, I think you've owned a couple wells, I think. Yeah. Most small wells in the US is just an on-off timer or some, rustic system like that.
That's how ours works. You get the breaker box where you can flip the power
Yeah.
on and off, and you have a timer there. And
Yeah.
keep it on 24 hours a day. You can keep it on. You can set a schedule for it if you
That's
wanted.
a couple
But
hundred
very
thousand wells.
rudimentary. Yeah.
Yep. Next year up, you have a kind of standard controller by the legacy guys, and if you time travel 25, 30 years, you will see different pickup truck on the well, but the exact same instrumentation, like exactly. And in the last 30 years, technology has evolved by tremendously. And so we wanted to bring all those new things, and we thought we could, make those wells produce better, detect all the leaks, control the wells, deal with the gas issues, and so on. And so we decided to build the system, and we saw in parallel the industrial automation in general, not just for oil field, isn't what it used to be. Like, to Charles' point, up until let's call it the 80s or so, industrial system were top notch and the most high tech thing you could find pretty much anywhere. Nowadays, the phone in my pocket is significantly better in pretty much every way compared to industrial system. It's easy to use. I don't have a 900-page manual to deal with it. It does way more computing, does it seamlessly. It's a very reliable piece of hardware. And you can, put apps and do anything with it, right? It's a platform. You can deploy stuff.
It's crazy. I just got the new iPhone 15 Pro a couple days ago. There are apps on the camera side that compete with these very expensive cameras right here.
Exactly.
It's astonishing.
Imagine that on an oil well, like the difference between, a well controller system and a SCADA system and that. You're beaming, people talk about all those buzzwords of big data and AI and whatnot. This is beaming back to, Apple and Samsung and whatever app you're using, huge amount of data and, about your behavior, about what you're doing with the phone. You're talking about, a million times more than what the industrial system beams back to the headquarters of a company. And because you have so much, then programmers, computer scientists, mathematicians are able to build those cool apps and cool application. And so how do you do that on the field, but taking into account the reality of an oil field, which is, stuff breaks, you're in a tough environment. You can't build a crazy system that's going to end up costing an arm and a leg because, most of the operators we deal with, they have between, call it, 100 and a couple thousand wells. They're not going to buy a 50 grand system times 1,000. Those are, we focus on PDP. Those are wells that, have been drilled already. People already spend their, multi-million dollar to drill and complete a well, and now you need to produce it. So you work on a much tighter budget, but you work at scale. So how do you make those technology accessible at scale? And that kind of led us to develop our own hardware. It's something that is not very trendy in the startup space. People try to, as much as possible, stick to software.
Did y'all think you were going to do hardware from the beginning, or do you think it was going to be
pretty much?
No, we knew from the beginning. The little bit of a cliche example I give, but I have in my apartment, I have an AC system, right? And so a big manufacturer, and I have this beautiful remote with 90 buttons on it, right? And I use on, off, and plus and minus.
Mm-hmm.
And this is the reality of industrial system on the wells, right? And then your foreman or your pumper is stuck with that machine that has a gigantic manual, and at the end of the day, you just want the equipment to run. So we knew we had to design something very simple that was easy to deploy, but that would at the same time be high-tech enough for us to be able to do the fancy analytics that we wanted to do in the back end. And we saw a need for it because the business model is also very different. Big automation company make money by selling you every 10 to 15 years a new expensive box, right? You have the box 1.0, and 12 years later you buy for another 20K the box 2.0, and so on. This isn't our approach. We make money by providing a service, and we want everything to just work. Like, if I can instrument everything, for you, I will. The value comes from the control, from the analytics, from, people don't care about the hardware. They just want the well to run. The hardware is effectively a necessary item. But
it's a means to an end for the analytics, right?
Yeah, exactly.
Yeah.
So it's a little, controversial for me to say, because I'm the one in charge of hardware in the company. I've designed all that. I think it's extremely important to have it, but if I do my job correctly, the hardware will be completely transparent.
And something also we were talking a little bit off record initially about AI is obviously top of mind for everyone. But I mean, having worked with big companies and being the guy who comes in and, okay, we're going to do some machine learning, or we're going to do some industrial AI project. Okay, well, so you go talk to the engineers who know about the process. You try to find prospect where, okay, where is there an actual use case that can make sense for you guys? And like very quickly you run into a situation where you talk with 30 guys, and every time you think you found something that's impactful, that works, and okay, do you have the data? Actually, we don't. Or what's the resolution of the data? Oh, it was compressed to 1 point a day. Or oh, actually the layout we have for the way everything is wired and organized is completely wrong. And so very often, like I think if you want to, there, like something which is very important, which is happening, is you need to have like those layers of people who come in and will basically help you to scrub all of that stuff and to organize it. But if you want to build like really high efficacy application, you need to, like, there is a bottleneck on how much data are you acquiring, how hard to do it, how messy is it, and how much of it do you get back. And the reality is, at the end of the day, if you want to do, like, there's a lot of value to be had by just, having clean KPI, not super sexy stuff, but just things well organized to keep track of, okay, at high level, here are my problems. But if you want to get into the more sophisticated workflows, like the kind of stuff that get people excited around, I don't know, predictive maintenance or production optimization, a lot of this stuff, you really need to unlock that whole pipeline from what's a sensor taking the data, how much am I losing when I'm transmitting that back, and how much am I losing when I'm storing it. Yeah. And if you don't do that, you end up trying to create, like, you end up trying to build a rocket, but your engine is from the 19th century.
Yeah.
And so
yeah,
you're not going to go very far.
So zooming out, SCADA is not a new concept, been around a long time. There's been some market leaders in the space for a long time. Like you're saying, some of that is now more antiquated technology. It could be a lot more expensive. Walk me through how you guys are doing this differently. And I'm assuming there's probably costs, probably the fidelity of the data, the frequency of the data, things like that, leveraging some of the newest tech. But also talk to me about what are the things that you're pulling off. I'm assuming it's probably maybe speed, stroke, I don't know, maybe temperature. I don't know if that plays into it, but like just walk me through how you guys are doing it differently and then what you guys are actually capturing on the hardware side. And then let's dive deeper onto the software side.
So to be very specific, we capture on the well, our kit is a few different sensors are placed around the well, little devices that talk wirelessly to one another, each recording, a different sensor like a couple hundred times a second.
Yeah.
Compared to, SCADA system is a point every 15 minutes. So when you record, for example.
Okay, so it's a bad comparison then.
Yeah.
Okay.
And, inherently it's the same, right?
It should be the same, but just there's a lot of constraints that come with what people traditionally call SCADA.
When you go for 100 times a second, you point every 15 minutes, you're talking about, 10,000, 100,000 more data. Your cloud infrastructure is completely different at that point. And by the way, the bulk of the work we do is the cloud infrastructure, because it's easy to say, I'm going to build a cloud, but building an infrastructure that can at scale handle in real time flow from thousands of devices at that resolution and then process it each at a different speed and so on, that's where a lot of the real know-how is. And that's the limitation with the current system. They're just not built on the technology that support that, or not even close, right? So but to go back to your question, so on the well, we measure, for example, your tubing pressure, your casing pressure, the sounds in the pipe. We measure the force on the well. We measure the vibration, the movement of the well, the current in the motor. I think that's about it on the well. So realistically, anything you need to know what's happening at the surface and what's happening downhole. And so from those measurements, you can tell downhole, how much gas there is at every single stroke. If your traveling valve is worn, your tubing is leaking, your whatever, your stuffing box is too tight, and so on. And with that, you couple that data with the other devices on the field. So we instrument the tank batteries, the injector wells, and so on. And that's something that sounds very obvious, but is not a common practice at all, tying what's happening between the well and the tanks. Very often you have it's basically
It's
different part of the
extremely
SCADA.
manual. Yeah.
Yeah. Either the pumper will gauge, the tanks by hand, and while the production engineers, deal with their well data, and they're literally connected by pipe, right?
Throw the chain down, or if you have a massive stick, there's
Yeah.
a couple different ways you can kind of gauge it
Well,
manually. And
I was gonna say
we
the
would go
meter
out and-
tape, but
we would go out and be like, oh shit, like we have a little bit of a leak on a valve, but we wouldn't know. We didn't have any automation on things. It was all completely manual, and the only way you even know that your tanks were full is because the pumper told you, and the pumper called in the run.
That sounds about right.
Yeah,
Wait until transfer pump fails.
yeah,
Exactly. Yeah, you have to deal with all the salt water injected, and basically by combining what's happening on all those pieces of machines together, you can model everything that's happening on the well. You can tell this well is producing this much oil, that's much water, it's going to this thing, and so on. And you can do that with actually very few sensors. You can, if you have what's happening at the well, what's happening at the tank, you can calculate everything after if you have the right amount of data. Because the traditional approach is a little bit to brute force everything. So, okay, I'm going to put a Coriolis meter, multi-phase flow meter everywhere. And, there's a 10 grand of sensor here, 10 grand of sensor there, maintenance, and so on. And before you know it, you have a system that is extremely expensive. So how do you do that with as a light hardware footprint as possible, but with as much computation after as possible to deal with all those details? And so it's doable. We've done it, right? You have the system I mentioned to you on the well, similar system on the tanks. You can detect all the leaks in the flow line in between. You can allocate, production. You can detect downhole issue. You can pretty much do anything that is needed. There's very few failures I can think of that we can't identify. We've seen early on there was a learning phase. Obviously, we built a system like, oh, what is this? It's like, oh yeah, it's because it was raining today. The belt was slipping, so the motor burns a little bit the rubber until the water evaporates, and then it grips the belt, and the whole well would start.
yeah.
Like go figure when it's the first time you see that signal that this is what was happening. Like there's no way. But if you have multiple signals at the same time, I'm like, okay, I see there's vibration on the wellhead and it's moving a little bit up and down. I see that the current of the motor is doing this thing. And now I can build a little system that will detect, okay, you need to go tighten the belt on that well, for example. So the bigger picture thing is like, it really doesn't matter what you're able to do today. What matters is what you will be able to develop. If you have all this data, you can just continuously release new feature, release new model, either ourselves or the customers has access to data and can build in-house stuff. You allow this feedback loop, this learning loop to happen. You're not stuck with the system that, oh, it can do X. Oh, you also want to detect Y by the new box 2.0, which, you're never going to do in the real world. So you have a system that becomes, that can evolve, like the way you update your phone.
Do you pull in power consumption?
Yeah.
Because that's really interesting, especially when you're talking about not only at the well site, but particularly on the saltwater disposal side. Like, is that something that you guys are actually able to optimize for? Because if you think about it, that's one of your biggest LOEs,
Yeah.
right? Is actually power, which is due typically to not only the well site, but the saltwater disposal, if you have it.
Yeah.
Right.
So the main thing we do there is it's region dependent, depending on which contract the operator have signed with the power company. But there's two big things you can do. One is you can switch your contract. You have a time of day use. Instead of paying a flat rate, you pay a variable rate per hours. But then you can tune, depending on your well, you can tune them to run more at time of, middle of the night, basically. Which, by the way, is the exact opposite of what a human typically does. 90% of foremans set the wells to run when they do their route. So, between 5 a.m. and noon or something, if they don't need to run the whole day. Versus that's typically, electricity is very expensive in the morning and when people are home, right? Early morning and end of afternoon, early evening. So you can do the opposite with the system. The second point is what's called a demand charge. Your power company bills you based on how much, kilowatt hour you burn, how many joules of energy you're using, and what's the peak power you do. And if you set all your wells to turn on and turn off at the same time, because people like round number, 90% of people will pick multiple 15 minutes, for example, you end up with a huge spikes of power. So now the power company has to put big transformer, big power lines, and so on. They charge you for that. if you have a
You just
system that
stagger by
automatically
5 minutes.
exactly you detect everything, you stagger it all. You know, this well has more horsepower, so I'm going to run it at the same
Yeah.
time as this tiny well, and so on. You can start to build, pretty much whatever you want at that point around the cost of electricity.
Especially if you're talking about starting really big pumps.
Yeah, those big injection pumps and
Yeah, like the
with
big
big
old
VFDs,
H pumps that just
Yeah.
suck up all the power.
triplex and H. And,
Yeah, that's
And you know, like when you say that, you're already thinking fancy stuff, but there is also simpler but important realities that say that you have a lease that's a little bit far off and you have to bring a truck to remove the water. How do you know exactly how much water was taken away, was owned by that truck, and that's what you get charged for? How do you know that maybe the truck just took a half load, but you paid the same price anyway? All kind of little stuff like
Yeah.
that. That you know,
there's a trust system based on tickets.
all kind of like quote unquote silly things. But you know, if you want to make things happen at scale in real life on the field, just being able to see, okay, like, yeah, the truck came and it came at the right time and we had a full load of water to dispose of, all of this kind of stuff. Like, we have a customer who have saved a lot of money by just basically telling the trucking company, stop coming every Monday. Just like, I'll call you when it's ready and you'll come pick it up.
Mhm. What have the results been so far with some of your customers on the optimization side?
Yeah, excellent. So we have very different kind of customers. We have some people that have, the oldest well I think we're on is 1917, 1918, vertical wells.
Still going strong.
Yeah. They're
Salt of the earth.
old school.
That's what I love about vertical wells.
I know,
Show
it's-
pumps that you're dead.
It just never stops. Two, our newest wells are early 2020-ish.
Yeah.
Horizontal big wells in the Permian. So and then anything in between. We have 14,000 feet wells. We have, what's the shallowest? We have, I don't know, 1,000, 1,500 foot maybe.
That's super shallow.
Couple water floods to horizontal to all that stuff, and different people look for different results. The main thing that people want is production increase, and that happen on average all our customer around plus 7% ish of production increase across all the wells.
7%.
Yeah, at 80 something a barrel, that's a lot. The second thing is around, depending on the operator, either reducing failure rate or basically cutting LOE, or finding spills. So, for example, we have some people that are in a swampy region, Louisiana, Mississippi. A spill there, you are in, reserves. It's measured in millions of dollars, the fine you're going to get after. So you really don't want your machinery to leak. Other places, when you have a well that's, deeper than 10,000 feet, maybe you don't want every last drop. Maybe you just want to never have to fix that well, because the rig crew is going to cost a fortune, or they're backed up and you're going to have to wait 3 months for them to be on
And
site.
you can operate so much leaner if you were able to do some sort of like predictive maintenance instead of having to worry about blowing something out and lose all that, all the NPT, there's no production, no revenue.
We saw it at the last freeze. I mean, this winter was relatively pretty mild. There were a couple of cold waves, and you see literally ice starts to form in the pipe, how the pressure slowly change. And so you can alert people, say, this is, you may want to turn off all the machinery and play it safe because nothing's heat traced over here. On the other end of the spectrum, you have some people that have a horizontal wells. It's having horrible gas slug issue and very complex pumping condition. Help us build an advanced control model to run that well. What do you do? And then we have, all the data. We can determine what's happening. We can try different control strategy, different mathematical models, and push that to the device so it runs that on the well. So you have different degrees of complexity depending on how, advanced the operator is.
Do you work only with certain kinds of lift, or is it pretty much across the board?
Today, so there are two things, like let's say the ecosystem of devices and the data pipeline. That stuff is pretty agnostic. But I think what you want to do, what we believe in is what you want to do is you don't want to serve people data. You really want to add the value out of processing and telling them, like, this is what's going on and this is a problem and here's how to fix it, or just simply driving the wells. So there is that piece of component that's more application oriented part is very specific to case by case. So today we started initially we planned to just be doing like basically pump jacks, and very quickly talking with operators we realized, okay, well, the pump jack's not living on its own. It has a tank battery, so we added the tank battery. Oh, and by the way, it also has an injection well it's connected to, so we also do the injection well. So today basically we do primarily pump jack, all the facilities around them, so tanks, injection, flow meters, this kind of stuff, and we've done a little bit of work on some small gas lift systems, but we are building a lot of integration for basically wells that already have some controllers, but where the data is stranded. So being able to integrate directly with that, ESPs, total flow. So that's like a pretty standard device to measure gas flows. Am I forgetting anything short term?
No, we've kind of put the gas market aside. Frankly, we were talking about plunger lifts for a while. Reality is price of gas hasn't been that high pretty much since we started the company. So in general, there's business wise, this doesn't make as much sense. So we focus on oil. But what you really want to do, to Charles' point, is you want to own a vertical and you need to know the physics of every machine. If you just build a beautiful data system that just provides a lot of data, effectively you just told the operator you need to hire more people to deal with this additional information I'm giving you, which most likely not going to do, right? People are already short-staffed enough, and it's hard enough to find engineers to do the work. People have more and more wells per person, both at the field level for the guys on the ground and at the engineering level. So you want to build the physics of every machine. You want to build the right control, and then you roll that application out. But that's the relatively, quote unquote, the easy part. If you had everything, all the data, you observe everything that happens. You talk to all the industry expert in the industry, and you can build something on top of it. It's building an app on the phone, right? Yeah. Simplifying things a little bit, but that's the system. And to go back to your question, is it working? So we're now in 10 different states. So when we were here 3 years ago, we started in Louisiana. We had a deal initially with an operator, which was very simple. We can do whatever we want on their field as long as we break nothing. In exchange, they'll get a sweetheart price when we're commercial. And so
that's usually how most people get started. Somebody takes a risk on you, right?
Yeah.
And we spend a lot of time in that swamp.
Retrospectively, I wouldn't have picked swampy Louisiana, but we spend our time in like horrible humid weather in the swamp. Like we're literally back and forth. We're doing 1 week in Boston, 1 week in Lausanne. When it iterate very quickly on the hardware, and you go from something that breaks every couple of months to something that lasts 10 years, right? And Louisiana was actually perfect for this because it's hot, it's wet, it's the worst environment for electronic. We had all kinds of fun failures. Like turns out that deers like to chew certain plastic. And so initially all cable were polyurethane, I think it was. And it has a certain smell, and the deers would come and chew those cables for the sensors. So we changed that. We observe behavior like hogs have learned how to open some tank valves. You're like, why did the tank just drain itself at night? So they would create a little swamp so they can go, like in a mud bath, in an oil bath, basically. We saw everything over there, and it was the best place to build a system. And that operator had, 600 something wells in the water flood. So we grew from there, and now we have between 1,000 and 1,500 system installed out there.
Yeah. On that, you just said water flood. So walk me through this. Are you guys, I'm assuming you're capturing information on whether could be maybe a couple different floods, right? You got water flood, you've got CO2 floods, steam floods, depending geographically where you're at. Are you guys pulling in that data to tie into the optimization as well?
Not yet. Not yet. We don't do optimization at the field level.
Okay.
That's the next. That was the vision when we started.
Yeah.
And then we realized that it didn't match the reality of the field. It was like, okay, we want to optimize the whole field. It's going to be great. There's a smart field. And wait, but every single well isn't optimized. And wait, to optimize a well, what do I need? I don't even have the data I need.
You got to crawl before you run.
It was exactly that. So it's I see it as this, I forgot how it's called, this basic needs pyramid, right? For human, you need first food and water, then a shelter, then at the end is, books and for your brain. It's a little bit the same thing here. Everyone wants the fancy high-end application that's the top of the pyramid, but if you don't have all the layers below, there's no point in even starting there.
And there is also like sales side to this, which is, we're a young company and hopefully we come up as trustworthy to people, but at the end of the day, we're a young company. People don't know us. Why would they trust us? And so if you're talking about effectively what you're describing is you want to be optimizing the reservoir side of thing. Now, immediately, like the timescales are months. Well, and that means that your sales cycle, because people are going to want to pilot it, the proof is in the pudding at the end of the day. So see what your results are. So now you're talking months. Well, if you start with the more day-to-day operation side of things, like that's really quick. Like you get like, you have a guy on location, the install is about 30 minutes. Within 30 minutes, you have data coming into the cloud. We run a couple of days of baseline. After that, we kick in. Boom. 1 week later, your production is up 30% on this well, or your runtime is down 70% on that well, and your production has not budged. So all of this kind of stuff, it's really like concrete and really quick to show the value. So when you are a young company, like having to prove yourself, that matters a lot to get that adoption where people can see quickly, okay, I tried, I see the benefit, okay, let's scale it up.
Yeah.
Well, once you're on the reservoir side, immediately, and reservoir engineers it takes a lot to, I used to do reservoir work, so it takes a lot to convince them, because there's a lot of fudge factor down there, lots of uncertainties, what exactly is going on in your system. So immediately you're looking at time scales for a young business that are way, way longer.
Yeah. On the software side, you pull all this data in. Mm-hmm. What is there's a lot of analytics out there. What's the differentiator? What makes you guys stand out?
I think at the end of the day, it's so it's two things. One is the resolution and the level of detail. So for instance, typically today, you have your SBOX system or whatever it is that you're, so talking about rod lift like pump jacks, one of the things you're going to want to look at was called Dynacard. So it's effectively like a little picture that tells you most of what you need to know about the health state of the pump. It's a little bit simplistic, like there is value in bringing other sensors, but it's a good starting point. Typically for most wells today, people have a couple of those snapshots a day. Now, I mean, you have operated a well, your well starts, your pump may be full, at some point it's going to be empty. Depending on when that snapshot fell, you get a completely different story about what's going on. And then let's not talking about, sometimes you just have wells that are dynamic, where you have gas interference, slugs, things like that. So being able to systematically get for every single stroke of your well, get the exact picture of, for every single stroke, here's what's going on, and like having that in context and being able to see to have this entire thing where you can tell exactly, okay, yeah, we see what's going on. The loads were here, now they are down there. Okay, and at the same time, the pressure dropped. Okay, we just have a tubing leak. Things like that. So that's one part, and then the second part is really looking at it like field wide, as Sebastian were mentioning, where now we don't do the full reservoir optimization, but the well is one part of the problem, and you have your well, but you also have the tanks, and so now you can cross-feed those data. You have your injector, same thing. All of those things get cross-fed so that you can tell things like, for instance, there are wells where you're going to have trade-offs between how hard you want to push your equipment and how much production you want to make. And sometimes it's clear cut, there's no question. Sometimes there just is a trade-off. So knowing what that trade-off, and very often like people have to rely basically on rule of thumbs on how to optimize. It's like, in this engineering group, like we want to push our well down to 70% fillage. This other group, it's 80%. And all of that stuff, people just don't have the information to make an informed decision. So it's kind of just, that's the wisdom. We've run by that, kind of works for us. It's what it is. So the idea is also to be able to, by crossing like that pump level data with the production data, for instance, on this kind of problem, you can get much more granular when you know exactly, okay, what is do I have a trade-off here? And if yes, where is it? And then it's up to the producer to say, well, on this one, I want to be pretty conservative or more aggressive, because more or less oil, more or less damage. So all things like that, bringing every piece of the puzzle together. And that's also pretty key for the spiel side. So obviously, as Seb mentioned, like methane is becoming a big thing, but liquid spill have been a big problem for a long time, and you drop salt water on the ground, like nothing is going to grow there for the next 50 years, right? So
Yeah.
you don't want that. At the end of the day, like people want to have good relations with neighbors. Often there are like cattle, farmland around, want to be respectful of those people. So being able to know, okay, what exactly is going on, which of my wells are running, what performance are they rolling at, how much liquid am I making? Everyone is pumping. I don't have downtime, but I'm making half of what I should be making. I have a big problem somewhere.
Yeah. Where do you guys see yourself in 5 years?
So
Don't overthink it.
yeah.
Just tell me pie in the sky. What's the vision?
We want to keep growing the company. This
Yeah.
is not a quick flip scheme. COVID put a little stop on our international ambition. This is all coming back now. We're starting to do our first deployment overseas. Conclusion for us is clear. There's a huge need for what we do. The customer, basically today we get all our customers by word of mouth. We get a customer A and then they intro us to their buddy, B and C.
Until today. And then this podcast is going to go out.
Exactly.
And you're going to get a whole bunch of people calling you.
We trust you.
And basically that works. And there's no limit to what you can do with the data. You can collect, right? There are limits of what we're capable of doing, but other people can build application on it, and that can be used. Other very kind of similar industries can use similar process. So right now the plan is to keep growing in this industry in the US. There's a lot of potential, obviously, and then doing the same thing overseas. 5 years from now, we'll probably be still doing pretty much that, and we'll reassess at that time. That's 5 years in a startup life is a long time.
It is. It's an eternity. We've only been doing this for 6 years total, so it's like so much can change so many different times. You never really know what the futures hold, but keep listening to your customers and you just keep on it. You'd be surprised to see where you go. And it's been really cool to see, like you said, you guys were here 3 years ago when you first kicked it off. You guys are just in Louisiana. You're here back growing. So it's so cool to see y'all's journey, and we'll have you guys on again soon and continue to follow along.
Looking forward to that.
Yeah, pleasure being here.
Absolutely, guys. Hey, y'all, take 2 seconds, leave a rating review, share this with your friends. We'll catch you guys in the next episode.